Okay, let's look at the last AP topic that just focuses on parametric equations. And in this topic, which is AP topic 9.3, we're going to find the length of a plane curve's arc. And so it's a pretty straightforward formula. However, it does involve integration, and sometimes the integration gets a little messy. Some of them might even just require a calculator. But here we go. First, the arc length of a plane curve over an interval from A to B is the integral of A to B, and then you're going to take the derivative of x and square it, add that to the derivative of y, square it, and take the square root of everything. And that square root of everything provides a little bit of a mess. You'll integrate that and you'll evaluate it from A to B, and then you'll have the length of the arc. Now, if you're ever asked for the distance that an arc travels or a particle travels over an arc, that's the same thing as the arc length. There are a couple of notes. You cannot find the arc length of a plane curve if it's not continuous and differentiable on that interval. So if it has any breaks or sharp turns, we cannot use this formula. And then one more thing, sometimes plane curves trace back over themselves. For example, a plane curve that is a circle will keep tracing back over itself. So for example, x equals cosine of t and y equals sine of t makes a circle. And what happens is after you've gone 2 pi, you're going to end up retracing. And so if you're ever asked for the arc length of a circle, you only want to go one cycle through the circle. Okay, so we're going to practice just one of these together. They're pretty long, intense problems, but the idea is the same for all of them. So if you can get this down, then you'll be in pretty good shape. Just the integration might be the worst part of it. So let's say that we have a parametric equation. The x is 2/3 t cubed, and the y is 3/2 t squared, and we want to find the length of the arc, or the arc length, over the interval 0 to 1, and that would be t being the interval 0 to 1. Okay, so the formula is going to be the integral from 0 to 1 of the square root, and we want the derivative of x, we're going to square it, and we want the derivative of y, and we're going to square it, and all that's in regard to t. So here we go. The integral from 0 to 1, the derivative of x, bring down that 3, it cancels out with the 3 on the bottom, and we get 2t squared. And remember, we're going to square that derivative. Get the derivative of y, bring that down that 2, it cancels out with a half, and we get 3t, and we're going to square that, and dt at the end. So what you want to do, if it's not a calculator problem, and this is an example of one that would not be a calculator problem, is you want to go ahead and really work this out and see what you can bring out of the square root, and then maybe we can use u substitution and keep working from there. And so let's just start simplifying inside the square root to see what we have. We'll take that square and get 4t to the 4th. We'll take that squared and get 9t squared. Looking for factors. We're always looking for factors, and I see I can get a t squared out of both of those. So I'm going to factor. So from 0 to 1, we have a t squared out, and that leaves 4t squared plus 9. Okay. Now what I see is that I can actually take the square root of t squared. And so that becomes a t on the outside. Now that's really a big deal, because hopefully you can recognize now that we have two sets of t's multiplied together, so 2 t factors. One of them is a power higher, so that's a prime candidate for u substitution. So I'm going to go over here and I'm going to say, let's let u equal 4t squared plus 9. We'll take the derivative of u, and that with respect to t, and that will be 8t dt. And then we'll solve for dt and get du is 8 over t. So over here we have the integral from 0 to 1 of t. We replace that 4t squared plus 9 with a u. replace the dt with a du over 8t. Our t's cancel out, and we can bring that 1 over 8 to the front. I'm going to leave my bounds in terms of t, and I'll just change it back to t here after I integrate the square root of u. All right, so the square root of u is u to the 3/2 divided by 3/2, so times 2/3. And that's all going to be evaluated from 0 to 1 in terms of t. We'll still fix that here on this next step right now. So my 2 and my 8 will reduce to 1 over 4. So we'll get 1 over 12 because we have 4 times 3. Let's replace our u back with what we substituted there at the top of the screen, 4t squared plus 9. And then all of that will be evaluated from 0 to 1. All right, we're getting close. Here we go. Let's plug 1 in. So we have 1/12. We'll just leave that 1/12 in there and figure that out at the end. So plugging 1 in, we'll get 4 times 1 squared is 4 plus 9 is 13. Then we'll plug 0 in, subtract off the lower bound 0. 4 times 0 is 0. We get 9. And oops, I did mess up. I'm going to put it on here. I forgot to put my 3/2 here whenever I replaced my u. The u had a 3/2, and I forgot to put it there. So we'll get a 3/2 there, and we'll put that 3/2 on each of these as well. So that was my fault. And of course, it's all times 1/12. So a little bit of a mess there. If you need to pause the video and clean up your work, then go and clean up your work as well. My fault. Okay, so we have, we can make this look like a radical, but at the end of the day, if it's not a calculator problem, maybe it would be converted into a radical, and then maybe, you would just try to match the answer to one of the multiple choice answers. If it is a calculator problem, then we probably would have put a lot of this into our calculator to begin with. But let's go ahead, and if we calculate this out with the calculator, we get 1.656, and that is the length of this arc. These two parametric equations from 0 to 1, they make something that looks kind of like this. It doesn't go very far, and the length of that is about 1.6, or yeah, it's about 1.656 whenever you round. All right, there you go. That's AP topic 9.3. That's kind of the last topic that's only about parametric equations. However, we will use parametric equations with some things that we do during the rest of this chapter. All right.